In this video lecture, we'll see the case study of the IoT device design and selection consideration. So the case study 1 is Smart Agriculture Node. Now the requirements for the Smart Agricultural Node are small size, low power, low cost, moderate memory. Small size is nothing but the device must be compact so that it can be easily placed in soil or attached to the plants. And small size helps in deploying many nodes across large agricultural fields. Second is the low power, where the devices usually run on the batteries or the solar power, so they must consume very little energy to work for long periods without maintenance. And coming to the low cost, farmers need multiple sensors across the field, keeping the cost low, which ensures wider adoption and better coverage. And the moderate memory is where the device needs enough memory to store the sensor readings temporarily, but very high memory is not required since the data is often sent to the cloud. So here the sensors which are used are the soil moisture sensor, then temperature sensor and the humidity sensor. Soil moisture sensor, it will measure the water content in the soil and it helps to decide when the irrigation is needed. And temperature sensor will monitor the environmental or the soil temperature, and it is important for the growth and weather based decisions. And the humidity sensor, it measures the moisture in the air and helps in understanding weather conditions and the plant health. So here the working of the system, it follows a simple flow here, like sensors, then sensors will collect the data, then it is sent to the microcontroller, which in turn is sent to the cloud or the server through the wireless transmission, and then to the farmer's module here. Now here the sensors, these sensors will collect the real-time data. That is, here we are using the soil moisture sensor, temperature sensor and the humidity sensor. And then microcontroller, it processes the data which is having the features such as it is a low power MCU, and here it performs the data acquisition, processing and the power management. So here the data is transmitted to the cloud or the gateway through the communication module, which may be a Wi-Fi, long range or the Zigbee. Then the farmer will monitor the data on the dashboard or the application. And if the soil moisture is low, then the alert is sent or irrigation system will turn on automatically. So this results in water saving along with the better crop growth. So here the device design consideration which are considered for this case study are power management, where we use here low power MCU. It goes into the sleep mode when it is not active, and here we use the solar charging in order to extend the battery life. Then the communication technology which is used are Wi-Fi, Zigbee and long range. Wi-Fi, it is used for short range, less than 100 meters. Then Zigbee for medium, that is in between, it ranges from 100 meters to 1 kilometer, and long range from 2 to 10 kilometer. And the use cases are, this Wi-Fi, it is used in the small farms, whereas Zigbee is used in sensor networks, and long range is used in large farms. Third consideration is the environmental protection, where we'll be having a waterproof enclosure, and it will be resistant to dust, rain and temperature. Waterproof enclosure such as IP65, then IP67. Then last one is the data processing, where the edge processing takes place. That is it processes the data locally and send only the important data. And the cloud processing, where it sends the raw data to the cloud for analysis and the visualization. So a smart agriculture node, it is designed to be simple, energy efficient and the cost effective, and it is a perfect example of practical IoT in the real life farming. So here the benefits are, it will save the water, it will improve the crop yield, then enables the remote monitoring and reduces the manual effort. Thank you.